Hello 171 class, this is Mr. Blevins. I am going to show you in this video how to make your slides for your functions project. So the first website I got up here is geogebra.org. I also have desmos.com/calculator, and then I have just a PowerPoint. You can use PowerPoint, you could use Google Slides, either one. And then a picture that you have taken yourself that you think looks like a straight line for this example. I have a picture of a couple kids on a seesaw, and I'm going to use the top of the seesaw as my linear function. Alright, so what you need to do, we're going to start off in GeoGebra. So this is again geogebra.org. I'm going to go to GeoGebra Classic, and once that opens up, I'm going to insert my picture onto this and put the picture in the background. So the way I do that, I'm going to highlight this A = 2. This is called a slider. I'm going to click on that, and I'm going to scroll down until I see image. Alright, and then it asks, alright, where is your image file? And I'll click the choose file, and then I'm going to select where I've got my image saved. So there's the seesaw, and I'm going to click open, and then OK. Now it'll ask, where do you want to put it? And I'm going to put it up here. It doesn't matter where you put it really. I'm going to put it up here in quadrant 1. Quadrant 1, remember, that's where X and Y are both positive. Alright, now notice it automatically puts these 2 points A and B on there. The only thing they're there for is to be able to resize it and drag it around. You don't need to have it on there. So I'm going to just remove those. The way you can remove those is just click the little dots up here. Alright, and then I'm going to right click anywhere on the picture. So as long as I'm inside the picture, I'm going to right click my mouse, and I'm going to click Object Properties, and then I'm going to select Background Image. Alright, and once I do that, it goes into the background. I can see the grid over top of it. I'm going to hit the little X over here in the corner. Alright, and then after I've got that on there, at this moment I've got the Move tool selected. I'm going to go over and select the Point tool. So I'm going to select Point, and then anywhere I click with my cursor, it'll put a point on the grid. So I'm going to just select, you have to have a minimum of 7 points as it says on the outline of the project. So I'm going to select 7 different points on there, at least 7. You can do more than 7. So there's 1, 2, 3, 4, 5, 6, 7, 8 points. Okay, and once I've got those points, I'm going from C to J. Now remember, A and B are not, they were the ones on the corners. So from C to J are the points that I'm using, and I'm going to take those into Desmos. Now this is really important that you understand this part. Once you've got your first tab open with GeoGebra, wherever you've got your Desmos tab, mine is up here out of the screen. Let me drag it up a little bit. So there's my Desmos tab. This is the current tab. I'm going to click the Desmos tab and hold it down, and then drag down, and now it becomes its own separate window. And the reason I do that, and I'm going to click again, is I want to be able to move this over a little bit to where I can see all the points that I have from GeoGebra behind this window from Desmos. That way when I transfer them over, I don't have to go back and forth and back and forth and back and forth. Okay, I can see all the points. Alright, now in Desmos, you're going to click Add Item, and you want a table. And notice this is calling it X1 and Y1. So I'm going to put all the X coordinates under X1. So 6.28 all the way down. And now I'm going to switch over to the Y coordinates under the Y column and put all the Y coordinates of these points in. Alright, and now as I've got the points put in, I can now drag this over till I see all the points. It's not a requirement that you see all the points, but it does help. If I made an error somewhere, for instance, if I accidentally hit 8 instead of 5, I would easily be able to see that that was out of the pattern. So even though you don't have to be able to see it, it sure does help to identify any errors that you made, potentially made. Now if I made a slight error here, if that last 4, if I had hit a 7 instead of a 4, I wouldn't have really been able to tell the difference there. But a lot of the errors it'll catch, and you'll be able to see something's way out of whack here. Okay, so this is a line. I think this is a line. If you remember the standard form of a line, or the slope-intercept form anyway, is y equals mx plus b. Well, these are my y's and these are my x's. So what I'm going to write down here on the next line is, instead of y equals mx plus b, I'm going to write y1. Alright, and then instead of equals, this is called a regression line. It's like an approximation. So since there's no approximately symbol on here, I'm going to use shift tilde, which is like Desmos's version of approximately. So y1 is approximately m times x1 plus b. All right, and what this does is it fills in what m and b need to be for this to work out, for my line to be, for this line to go through this set of data. So what it's showing me is if I choose this to be m and I choose this to be b, then this is what line I would get, and it goes through almost every point in the data. Alright, so there's how do I get my model for these things. R squared, this number right here, is kind of like a grade. Don't worry about R, it'll only show up for lines and exponentials, but R squared is a measure of how well this line fits our data. So since this is a picture of a seesaw, remember, we can also think of it as how well a line models a seesaw. So it's a number, R squared is a number between 0 and 1, and the closer it is to 1, the better our image is at being represented by whatever we think the function is. So because this is almost 1 exactly, that means that this is an almost perfect representation of a line. Our seesaw is. Alright, so now what I'm going to do, I'm going to split screen this. So I'm going to drag again from the top. I'm going to drag this to the right, and it'll come over and join the right hand side. And I'll do the same thing. I'll click up here and I'll drag to the left. And now I've got a split screen going on. Now I'm going to get rid of this in just a second, but I'm doing it long enough to where I can see this next input line on GeoGebra. See where it says input right here. And what I'm going to do is I'm going to type this equation that Desmos gave me. So instead of y1, I'm back to y equals. Instead of tilde, I'm back to equals. M is this number right here. I'm going to round it to 4 places. So 0.3575. Alright, and then x, instead of x1, I'm back to x. And then plus b, b is this other number. So I did 4 decimal places. So I'm going to do 4 decimal places here as well. So 1.059, or 4 significant figures. 1.059. Alright, and then if I go back, I'll blow this back up. If I go back to GeoGebra, there's now a line going through the data where I am representing this seesaw, the top of this seesaw. Okay. If I don't like the color, like if I feel like I can't see that line well enough, you can right click on the line. Moved over there. Right click on the line, click on Object Properties, and then go up here to Color, and I could change it to red or green or whatever color I think would look the best and make it the most visible. You can also go to Style and make it a little bit thicker if you don't think it's visible enough. All right. So and you can make it dashed. I don't know why you'd want to do that, but you could if you wanted to. So anyway, that's how you make your model, your function model, go through the actual picture, which is a requirement. Alright, and then the last thing, I would use the snipping tool. Most things have this, you just have to take a screenshot and edit it down. But take a snipping tool, snip of the image with the axes in place. So try to get your X and Y axis in there. And there's my Y axis, there's my X axis. And then hit this button right here on snipping tool is copy. And then bring your PowerPoint slide up and Control V or just edit paste. And now you've got your image in on your slide. Alright, so that's how you do the slide. Look through the examples. Look through the examples on the functions project on what you need to do. So if you click on there, you can see what all is required, what you're going to be graded on, and you can also see examples of what has made an A in the past. So here's an example of how to make the PDF form of this thing. So this is their linear function, their equations, and you can see what needs to go into every slide. So there needs to be a description, something based on r squared, and the image obviously itself. So just read through that, read through the examples, and start making those slides. If you have questions, send me an email. But you need to get started on that. You don't want to try to do this the last weekend that's due, because it takes hours to do it.